Day 68, Rotational Kinematics, problem 25, page 272. I don't have a yellow marker here, so I'm using red for the wheel. Obviously the chimp isn't that important, just kind of a fun way to think about the problem. The radius of the wheel is 10 inches, diameter is 20. So the first thing is I convert that into centimeters, and actually I'm going to convert that to meters, 0.254 meters. So there's at least a couple ways to do this problem, basically by just straight conversion. If you have 100 rotations per minute, and there's one full circle in a rotation, 2 pi r, so this right here gives me one full circumference of a circle, that many meters in one rotation. That would get me to meters per minute. And then I want to convert into seconds. So 1 minute is 60 seconds. So I just did this by straight conversions. You get 2.66 meters per second. That's one way to do it. That's the way I would probably do it. Or down here at the bottom, what you can do is, as you see here, just convert to radians per second first. Sometimes you have to do that. You have 100 rotations per minute again, times 2 pi radians in one rotation. That will get you to radians per minute, and then do your conversions into seconds. Bottom line, sometimes you'll be doing this quite a bit. It always comes out that way. If you're in rotations per minute, essentially you're going to multiply by pi over 30, because the 2 and the 60 will be 1 over 30 reduced. So it'll be pi over 30, which you can also just figure out in decimal form. It's going to be about, pi is about 3 over 30, so it's going to be about 0.1. So bottom line is, if you take about 1/10 of this to a close approximation, you get how many radians per second. So whenever you have the rotations per minute, if you take 10% of it, you're real close to how many radians per second you have. And then once you have that, then you go down here to your relationship between linear or tangential velocity. The v here is the tangential velocity at a given radius, knowing the rotational speed omega, which we now know is 10.5 radians per second. So if we plug into there, we're looking for the tangential speed. V equals r in meters, 0.254, times my rotational speed in radians per second, 10.5 radians per second. I get the same answer. The velocity here is 2.66. The tangential velocity at a point 10 inches from, or 25.4 centimeters from the center of rotation, and that's my SI units for my tangential velocity.